these things out, find what you know and then write it out. Simple as like this where it makes sense to you, because this is almost the same thing, but it's easier for me. It works in my mind. So just being able to find the problem here, add your equation, and then plug in what you know, and always end up checking. This is another word problem that is going to be, that was in chapter 9. And these aren't too bad, but I feel like they come up often and it's very important to know. So I put here some the formulas that you need. These are going to be like distance rate problems, or when people work together situations. So D is distance, R is rate, and T is time. And what if you don't know what needs to be known, if it asks you what's the time of them working together, these are what you need to find out, the unknown. And this is either what's given or what needs to be worked to, these options in this work. And then if you're a visual learner, you can end up using a chart here to kind of figure out what you need to do. But let's try this problem really quickly with the amount of space that I have left. It says Sarah, this is supposed to be left. Sarah left San Diego going east. She traveled 60 miles per hour. Ruby, she followed. She left 2 hours later at 70 miles per hour. When will Ruby reach Sarah? So Sarah's left first. They're both going to the same destination, but the biggest thing is going to be that they left at different times, and their rate or their speed is different. So that is really important when it comes to this question here. We know in this one we're trying to find time as far as when they'll reach each other. So we're going to have, I would use this one here. Time is the distance that is amount of being covered. And back to what I was saying about algebra expressions here, in this problem, this is really important because we know that time is going to be whatever we find out minus 2 hours, because they didn't leave together. They left 2 hours difference, but their speed is different. So let me kind of help set up this equation here. I'm going to do 60t, that's the time that we need to find out, equals 70. That's Ruby's miles per hour. And that's also time minus I take that back. In this problem, let's set it up like this. We know this is really important. I mentioned this because of the algebra expression portion, but 60 t equals 70, and then I'm going to plug that in. I missed that first step when I was explaining to you guys. And then 60 t equals, you'll end up distributing here, 7t. We're going to multiply there, that's 140. So we need to get our t's on one side and our numbers on the other side. So I'm going to end up, for this problem, I would subtract here, minus 70 minus this. You're going to get t equals 140. And then the same thing we did with the first problem. When it's pretty simple from there, just divide. T equals 14. So we know one part of the question here is that Sarah's time, Ruby, because that's initially what we're trying to find out when she'll reach, is going to be 14. So we'll use this and then we can check and plug it in here. So T equals 2 is 14. And then we can plug in what we know here as far as like the 2 hours options. So 14 minus 2 is 12. It would take her 12 hours to catch up to Sarah. So Ruby rate, she equals 12 hours for them to reach Sarah. And if it's easier for you, you can plug it in here. I just personally like to see where I made a mistake, like in the beginning, how I realized I didn't do that correct, where I jumped the gun. So I'll end up multiplying. This is the first option, but I put this here because I'm not the 100. It's more, it makes me feel comfortable to know I need to figure out this equation, because time was 14 hours minus 2 because Ruby left 2 hours after Sarah, and that gives me 12. Thank you.